video today, so I'm sorry about that. But I will talk about some other things that you will find, that you will recognize, I think. So, first I wanted to put in a little plug for my group. My group is, as Chat said, situ, and we do work on interaction paradigms, participatory design, distributed communication, engineering platforms. Right now we have about 20 researchers, 6 faculty, a dozen PhD students, and various postdocs and research engineers and other people. So we are actually hiring, so if you're interested, or we also have a lovely master's program that is international, all taught in English. The lab has people from all over the world. We also speak English. There's a few Germans, 2 others. Anyway, all right, so I'm also going to refer back to a talk. So Michel over here, Michel Baudouin-Lafont, is kind of my partner in crime here on a lot of this, and he gave a talk on Monday night for ETH, so there may be a few people in the audience who heard him talk about perspectives on how do we create unified principles of interaction. How is it that we make human beings interact better with technology? And so he talked about things like instrumental interaction and substrates, and there's all kinds of really useful, interesting stuff that we can do that will help you build much better interaction systems, and I won't talk about any of that, but go find his video. I'm sure it's on the web. It's at ETH, right? So now I'm going to take less of, both of these are human system perspectives, but the first one was sort of how would I build something like this, and there's a lot of things to be said. Today I'm going to talk about the process of using interactive systems, the basic way in which we as human beings interact with technology, and to create what I used to call co-adaptive systems, but it turns out that human-computer partnerships sells a whole lot better, so I did that. Anyway, now, when we think about interacting with computers, we can think about it from 3 different perspectives, if we make it simple. We can think of a computer as a tool, some kind of object or interactive device that we use that empowers us to do something else. We can also think of it as a servant to which we delegate tasks. That's generally the domain of AI and machine learning. The first one I would call human-computer interaction, my field. And the last is the computer as a medium. Now that's actually been around for 40 years or so, but it's only generally been viewed by the general public as something interesting with the advent of social media. So that's where we are. All right, now I'm going to do a little bit of challenging of the traditional AI approach and how they treat the human in the loop. So generally, if you ask a machine learning researcher, which I suspect some of you are, how many of you would say you do work in machine learning, out of curiosity? Oh, not so many. All right, okay, so I'm going to go tell your, well, we'll see. All right, see what you think. So basically, if you talk to a machine learning researcher and you say, they say, I'm going to put the human in the loop, we're going to think about that, what they will do is think about how the human being helps improve their algorithm. And basically what they do is they measure the quality of the algorithm, which is perfectly fine. There are a lot of really useful uses of machine learning, and it's really important to have good algorithms. But if you think about, so actually this is a really good example. Google has very, very powerful machine learning algorithms. And what you have here is I, as a user, type something in. As I start to type, Google says, oh, you type GOO, and it gives me some things I might want to do based partly on what the rest of the world does, based partly on my own history with Google, and it puts that all together and gives me useful suggestions, and then I choose. I mainly control it. I don't understand how the algorithms work, but I'm in the process of doing it. It's a fairly simple interface, and I get to choose. So I feel like that's a partnership at a very simple level. But we have these kinds of partnerships, ones in which the user is a cog in the wheel. The user is basically not viewed in terms of how can we empower the user, but how can we use the user's input to make the algorithm better. So what we're trying to do is think about how can we rethink things like machine learning algorithms in the service of the user, to make the user better, to make the user more productive, happier, more expressive, whatever.
So instead of thinking of human in the loop, where we improve the algorithm, what we want to do is think about the opposite, which is computer in the loop, which is to empower the user. Now, if you think about it, it's a loop. So the focus is not whether we go back and forth between the human user and the algorithm, but where do we focus our interest? What is it that we measure when we're thinking about success? Do we think about a user who is more powerful or an algorithm that is more powerful? All right? So this is the idea where instead of only creating models of users and feeding them into the system to inform the system, there's the other approach, which is say, how do we create models of the system that inform the user? How do we reveal what's happening in the system in a way that the user can understand, remain in control of, and use productively for their own purposes? So that is what I want in a human-computer partnership. I want to be able to think about how we take advantage of people who are really good at doing this, but in service of that. All right, now, there are several metaphors, and we're not here yet, but I'm going to give you some examples of what a partnership could be and why you don't want to have one kind of partnership. So the first one is, let's think about human transportation interaction. So I want to go home, and I can take a taxi, right? And if it's Friday night and I've been drinking, maybe I should take a taxi. Maybe that's the best way for me to get home. I am not in control. I abdicate the control to the driver. I might give them an instruction, but they will take me there. So that's one form of thing. And if you think about self-driving cars, that's a vision of the future where everybody will just have this magical servant that's going to take us wherever we want to go. Okay. But some people like to be in control. Some people like to drive a motorcycle. Now this takes training. This person has been licensed, this person has probably fallen off a few times, this person is a skilled user. They probably should not get on that motorcycle when they've been drinking on Friday night. So the fact that the taxi exists is a really good idea. But if you said to him, yeah, no more motorcycle, we've taken away your license, and you're only going to have taxis, he's going to be unhappy, right? Now, there's a third model. This is, he's entirely in control. The taxi is the taxi driver's in control. The third one is an interesting one, and we don't know how to do this yet, but this is what I would like. Here we have somebody who is a skilled user, a skilled human being who's learned how to ride. If she's drunk on a Friday night, the horse may get her home. There's some intelligence in that brain. But she can go galloping on the beach and have a wonderful time, right? So there's this mix of how do we think about sharing the control in a productive way so that according to the context and according to the user's skills, we create a partnership that's effective for the human being, okay? So how do we do this? Well, I will argue that if I'm going to interact with a system, I need at least three things. I need other things too, but these are the three that I happen to be interested in primarily. So we need the ability to discover how it works. I want that system to reveal what's going on in a form that's relevant to me at the time I need to interact, right? I want to appropriate it. That means that I want it to be something that I can control and use its properties in different ways according to different circumstances. And finally, I want to be able to express myself. Now, I'm not talking about making the system smart and detecting how I feel. That's one thing. But I actually want to be able to express who I am and have another human being on the other side of a mediation with this computer, where my ability to be myself with all my faults and creativeness and whatever shows up on the other side. And that's what I mean by expressivity. So let me show you some sort of thinking about how we think about this. All right, we take as a model the way that we as human beings interact in the world with physical tools. And I love this because the more you look at it, the weirder it looks. So what we have is the concept of affordances from James Gibson. I won't go into detail, but the basic idea is that we as human beings or animals, we respond to the properties of objects in the world. And that allows us to appropriate them. If I take this pen, it was designed as a pen, I could write on it. I could write on my hand, I could write on here, Chat would be mad at me. I could write on here, that would be okay. I could use it to tie up my hair. I could use it to, as a straight edge, right, draw a straight line. I understand the physical properties of this, all right? Now here what's happening is, what is this? Is this a cutting board? Is this a picture of a cutting board? Well, it's kind of both, right? I mean, an iPad is actually a pretty good cutting surface, you know, so actually the physics of it work. But, you know, there's actually a physical cutting board underneath. Anyway, I find that fascinating. I'll look at it a lot. All right, so what do we learn from physical tools? So we as designers of tools, we're great users of tools. We often create them to do particular tasks that we understand. Like here we have a hammer, and we can hammer a nail. But if I don't happen to have a hammer, I can use a shoe, right? The idea is that the properties of how strong that is and its shape and so on will allow me to accomplish the same task. This is rare in computing systems. This kind of flexibility is rare, and we need to build that in. Oops, did I lose a slide? No, I didn't. Okay, so there's another thing that is often missing, and this is related to this term discoverability. When we create physical tools like this, it takes time to learn them. But some users become virtuosos. I think that's Joshua Bell. He's very good at violin, much better than I am. We have this notion of incrementally learnable. We do not have some software manufacturer coming in and saying to him, it's time to upgrade your violin. We're going to change the number of strings. We're going to make it tuned differently. We're going to add this thing on the end that you don't want, but it's going to get in the way. That kind of thing, they don't do. And so there's a certain level of stability in terms of the way that he interacts with that object that allows him to develop skills, empowers him as a user. It requires skill on his part, right? The violin isn't doing it for him. But at the same time, as he gets better, he gets more out of it, right? So the question we have is, why isn't software letting us start out and do something that's fairly simple at an early phase and be productive and do that? That's great. But then move all the way to virtuoso performance. If we study graphic designers using InDesign or Illustrator, yeah, they get pretty good at it. But they don't get to this level. The software doesn't let you grow and build your, even if it's a tool that you've used for 20 or 30 years, you do not make that level in computer tools, right? So, let me take my little white rat, which I'm going to use as an explanatory system, and show you, like, let's take a smartphone. What can we do with a smartphone? How many of you have a smartphone? Okay, not so surprising, right? This is a really brilliant design. There's a lot of wonderful things about a smartphone. But the interface is very restricted. And there are various reasons for that. If you want a billion people to use a smartphone, it's going to have a simple interface. So here's a smartphone. This happens to be mine. It's a little old. I've had it for a while. A computer like this is more powerful than what got astronauts to the moon. This is an extraordinary piece of hardware that we take for granted because, well, everybody's got one. This is an extraordinary input device and output device, by the way. The brain, I have a hand, it's very flexible, very subtle. I can tell the difference between touching that and touching that, slightly different. Tremendous difference. So what have we got? We've got this incredible device, an incredible human being with all kinds of motor and visual and cognitive capabilities, And we let you tap and drag and swipe and pinch. And now you're done. At the level of interaction, that's where you are. So, what would it be like if we had devices like this, but that we could truly interact with them and have a much more expressive, powerful, yet still simple way to interact, okay? So, we have what we call the power simplicity curve. There's a fundamental trade-off in systems. Now, the smartphone is kind of down here, right? We have this simple set of buttons and we can poke at things, and somebody has designed an interface for us, and then we react to that. It's what's called a graphical user interface. It was developed almost 40 years ago for executive secretaries, and we're all basically living in that paradigm. Now, if I took a system, say, for example, for editing video, because I will talk about video just a tiny bit, if I have QuickTime, I can trim and I can play, can't do a whole lot, but it's super simple. It's very easy to understand. If I go to Final Cut Pro, I'm over here, and it's really complex, and I have to spend a lot of time learning it, and then when they change the interface, I'm going to have to learn it again. I could build on some skills, but not others. When I shift from Final Cut to Adobe Premiere, I'm going to lose some things. It's complicated. All right, so this is like the taxi versus the motorcycle versus the horse. Do we just have to choose? Do we just have to say every piece of software is somewhere on that curve? Or do we think about how we move that curve? How do I make interfaces that retain a certain level of simplicity but become more powerful? I can go this way or I can go this way, and both of those are better. So that's what we're going to try to do. We're going to try to keep things that are simple, simple. A button, that's fine. I can poke it, it works, fine. But I want to be able to do more complex things, and I want to do it in an incrementally learnable way. So this gets to this thing about co-adaptive systems. If you watch how people interact with technology, they do two things. They learn how it works. They adapt their skills based on how it works. And one of the first things you do when you learn a new piece of software is you figure out how it works. Ideally, you figure it out with the idea that you're going to do something that you want to do. Okay? But the other thing that we do is we adapt that technology. We appropriate it. And that is rarely designed for. So I come at this from the perspective of an HCI interaction designer, and I say, why are we thinking about a user interface where we're going to think about the user experience? I'm going to design that user experience. It doesn't work that way. Human beings always adapt. They adapt physical objects, as I explained, but they also adapt technology. Does anybody know, can you think of an example of a piece of interactive technology that's a little bit newer than text editing, but not much, and transformed business? What would that be? What piece of technology?
ERP systems.
I was going to say the spreadsheet. The spreadsheet, right? The spreadsheet was designed by somebody who was bored in class. Dan Bricklin sat in an accounting class and had a pencil and a big eraser, and he had to write down a whole bunch of numbers and add them up bit by bit by bit, add them all up by hand. And he said, oh, I've got this computer over here, very low power computer, not like that, but it can add up numbers. And he did a brilliant thing. Instead of thinking, I'm just going to do totals, he made it work in both directions. There's rows and columns, and there's tiny bits of computation that are embedded in these cells, and there's a systematic way of referring from one cell to another. And with that, we changed business. He changed business. So what I mean by that is, what if spreadsheeting, what if accounting comes in, budgeting is what you take for granted. So if you had a budget, you had a bunch of numbers, it would not occur to you that the only thing you can do is add up numbers at the bottom. You could say, what happens if I hire 3 more people? Or what happens if I change the percentage and get a higher rate of return? What if, what if, what if? And so the system did that. And then what happened is, in observing people, people discovered that they could create all kinds of things, anything that you can make a working circuit in with just ones and zeros in your spreadsheet. You can create posters. How many of you have created a poster in a spreadsheet? Anybody? Oh, you're not very, okay. It's a really good tool for making spreadsheets. Anyway, the idea is that there is a little bit of technology out there that has certain principles that you can appropriate, like a spreadsheet, but not a lot. So there's another thing here, which is the notion of co-adaptation refers to what people do. People adapt their behavior to the technology, and they adapt it for their own purposes. But interestingly, computers can do that too. So what we call AI is they adapt to people. It's observing what I'm doing. There might be a neural net, there might be some kind of reinforcement learning algorithm, there could be any one of a number of things where it's learning what I'm doing, and it can adapt my behavior. So I say CAI, which is computer-aided instruction, that's the kind of nice one. There's also persuasive technologies where you're trying to get people to buy things. Both of those happen, and when we design technology, if you start building in this, you have to understand that it's going to have a very complex effect on the people who are using that technology. All right, now I'm going to give you some specific examples because I've talked too much at the high level, and I would like to go back to my wonderful phone and think about what I can do with gestures and gesture interaction on a phone. All right, so the first thing is discoverability. Why is it that I don't interact with my phone with gestures? Well, they may be fast and easy. I could do them eyes free, do a gesture like call mom, and I make a particular thing, and it calls mom, and I can say hi mom, and so on. Why doesn't that exist? Because I'd have to learn that gesture, and I'd have to assign it to my mom because I don't want to call your mom, right? So how do we create that sort of thing? Well, the first thing we want to do is I have to be able to learn what gestures already exist. So we have a system that we did actually almost 10 years ago now called Octopocus. Interesting name. And the idea is that if you're an expert, you want to just say that. So that's the cut command. I make that gesture, I'm done. But if I'm a novice, what do? I don't know what that command is. How do I make the cut command? Well, I hesitate. And when I hesitate, there's a guide that appears. And it says, well, if you do this, it's cut. If you do that, it's copy. And if you do that, it's paste. And it's contextual, which means that I start going here and I pause here. It's not going to tell me I can paste because I can't anymore. The algorithm won't understand that. But it will let me continue on with a slightly thinner gesture to cut, or I could copy. So what's happening here is the system is revealing a number of things. It's revealing what gestures it has. It's revealing what I've already done, that's a feedback, and it's revealing what's still possible for me to do, all in a very lightweight, simple, graphical interface. So we have what we call progressive feed forward, which is kind of a dynamic guide that tells me what could happen, and progressive feedback that says what's already happened from the system's perspective. So I'm revealing the system, but in terms that the user understands. So let me just show you here. This is doing the help command. It'll show a couple times. So that's the help, and you see. So this is an example of pausing at the beginning. I get to see the full menu, and then I just draw help. Now, if I do this, this is novice mode. We get the whole thing. You see it enough times, you get it. Intermediate, I start drawing, and then I hesitate. It says, oh, finish like that, and it'll be recognized as help. And then the expert mode, I just do it. So the idea is very simple here. Now, what else can I do? How can I learn new commands, gestures that execute commands? So this is actually a fairly new piece of work that we just published. We have a system that was invented by Shuman Jai and Per-Ole Christensen a number of years ago, which is called gesture typing. Any of you use gesture typing to interact? Not too many. Okay. Well, the basic idea is that when you normally interact with a phone, you type your words like that. So most of you do that. You might do it with your thumbs. Here, I draw the word news. I have good news, so N-E-W-S, and I just draw from letter to letter. And that turns out to be significantly faster, and it's kind of nice. It's gesture-based. Now, if you see what's happening here, you see it's leaving a trace, and you can see what's happening. And I will show you, I will slow this down for you a little bit. If I can, there we go. All right, so what we're doing is we're transforming gestures into command. Gesture typing exists already. We're going to take advantage of gesture typing, but use it to transform my little phone here into having a full command line interface at my fingertips. So those of you who are Linux programmers or interested in using that kind of more powerful technology where you know something and you can enter commands, you can do that with this technique, right? So here's an example. I draw the word Alice, A-L-I-C-E. The system, instead of saying, it could say it's just Alex, or it could say, oh, you have somebody named Alice in your contact list. And so, which of the two? Will it be Alice Brooke or Alice Waltz? Here, we're going to choose the context Alice Brooke. And now, cool, now I'm in gesture mode, and now I'm above the standard soft keyboard here. And what it does is it says, well, do you want to call, text, use WhatsApp, email? And I can specify with that same technique we saw before, I get a bunch of options. And I can, again, if I pause, I get what the options are. And if I just do the gesture, I can do it. So now I start writing and I have the full gesture, but it can be any command in the command space. So this is sort of showing you slowed down. You see the octopus style thing. Here we get calling Alice Brooke directly from the phone. This all really works. This is on an Android phone. And one of the things that we've done here is transformed this space, which is normally not an interaction space, into a fully interactive space that is now allowing us to accept commands. So we formerly had the text input space down here. We had the normal suggestion bar. This is now a command bar, which gives us what is available in the command space, and then a variety of different ways of executing different gestures. So this turns out to be very fast and efficient, and people really like it because they can figure out how it works. And I like that one just because they do practice their gestures on the side. All right. Now, what's interesting is once you start with a concept like this, you can start pushing it in different directions. And we have two fundamental ideas. One is that I can draw a command, any command down here, and because anything that, I should say this, anything that's in black exists already on your phone. So that's the current world. Anything that's green is what we're introducing here with this command board. So the command board, the command bar, gives you access to the command space. What are the commands that are available? And some of those commands take parameters, so you can use gestures to make commands. We can draw gestures, we can execute commands, we can do gesture shortcuts, and we have a variety of different ways of interacting. So let me show you a few examples here. This is what I've already shown you, and here we say, all right, I'm going to type the word happy, and then I can choose whether to make it italic, bold, underline, whatever. And it's just in the text as I go. All I have to do is type my word, go up, and I go, right? And if I learn that gesture, then I can make it bold or colored or whatever as I go. This one is a parametric command. So I start writing the word brightness. I don't have to write all the way through brightness because it knows that brightness is actually a command. And so I scoot up here, and when I do, I get a slider, and I can adjust exactly how much brightness. So it knows that that's a parameterized command. Another one that I can do, which is actually very useful if there is no sort of parameter or whatever, I can say, here's an example. I want to change the font type, or the font type to sans mono. Now, this is the universal execute command. So anytime I write a command with the keyboard, if I just do that, it says execute it, and it's done. So if I know the name of the command, I don't have to have it suggested to me. I can just execute it. And finally, here's an alternative way of doing, I can write the word brush, I want to create a brush that I'm going to use to draw up here. I go up here and I can say, well, what kind of edge do I want? This is what's called a marking menu, and I go here and I can choose the width. So we have this very powerful, flexible way of interacting to a full command set, which goes far beyond what we've got right now. And I just like these two because I can write the word color and then choose the color, insert a table, etc. All right, now, how can I appropriate these? So I said there were three things. There's discoverability. Now we have appropriability. Well, we have a technique that we use that allows us to balance a fundamental trade-off that we have. If I'm going to create my own command for call mom, it has to not interfere with any existing commands that are in the system. So I have to create a command that I can remember, and the system has to be able to recognize it. Okay? So we have a system here where we display a field, multicolored field that goes from red to blue, not red to green because color blindness and so on. So this should work with everybody. If I stop in red, it's revealing to me that this circle gesture already is mapped to a command, and I shouldn't stop there. Or else I could use it and overwrite the old circle command and give it a new name. But if it ends in blue, then that's going to work. So this user started with a circle and said, oh, can't stop there. I need something a little more complicated. And so continued down, stopped in a blue, and now that looks like a clock, and so that's her reminder to do something. So she's created a mnemonic gesture that is easy for her to remember and is unique from the system's point of view. So in theory, we should see this. So here you see some examples ending in red. Triangle wasn't going to work. So this is mapping things like a Facebook song that I'm listening to with somebody. We end in the red zone. We say, no, it's going to have to be more complicated than a triangle. If it ends in blue, it will be understood. So you make a little tail. And basically what happens is that people find it very easy and lightweight to start creating these gestures. There's certain things like they tend to just add more to the gesture. And so anyway, there's lots to be said there, but I will keep going. Now, there's another piece that we've been playing with recently, which is how do I generate expressive text? So if you look at handwritten text, it's very expressive. You can't help it. If you write by hand, and you write by hand, it won't be the same, right? And if I ask both of you to be sitting and write something, and then I ask you both to stand up and start walking, I will be able to tell the difference. And we actually have done that study, and it turns out that all four of those conditions are very different. Now, what happens if I do exactly the same thing? I ask you both to type the same thing on your phone. It's all going to look the same. I will not be able to tell that you wrote it, and I won't be able to tell that you were walking when you wrote it. That's all gone. All right, so what's really happening here? The machine learning algorithms that we've got are set up with the idea that the goal is to classify the word. They're trying to guess what is the word that I want. I'm trying to write the word happy, I'm trying to do something else. And so the human variation in that gesture is viewed as noise. And what do we do with noise? We get rid of it. It's a bad thing. So look here, they're great. All these algorithms, you saw that? That word, great, is interpreted. These are all different ways that human beings have written the word great. And the algorithm is very robust. It can figure all that out. Yay, algorithm, wonderful. But is that all we want? Is there something else we can do? Because what that does is we all get the identical result at the end. But we're all different. So what happens if we transform that variation into variations in the output? So here, this runs several times. So I'm going to show this to you because it's a complex diagram. But here we are. We have a rich gesture. The recognizer says, what word is it? It's trying desperately to figure out what word it is. But we also do some feature analysis. And we say, let's map that to, for example, color or font or the expression on an emoji. So let me break that down a little bit. Text, color, font, whatever. There we go. So here, this is a case of changing the color and the emojis. I think I'm just playing this. Somehow that one got in there twice. Sorry about that. This one is color. Now, why do we use color? Well, we can reliably detect the difference between red and green and blue as users, but also from the systems. So here, if I write inflated, straight, constant speed, it goes red. Curvy, it goes green. If I make it fast and then slow, it goes blue, and so on. So I, as a user, can learn to control the entire RGB color space just through variations of 3 features. Curviness, I believe curviness is mapped to red. Inflation, that means size, is mapped to, let's see, blue, yes. And then the last one is green, and that is curviness. Okay, well, anyway, curviness, inflation, and speed variation. Those are the 3. All right. So let me see what else you can do. So here we have words, and now here we've written the word emoji, so now it's a command, and the emoji gets put in, but depending on how I draw that emoji, it gives me a different expression, and I can even do things like animated emojis. Yes, question?
How important is the locality of the gesture that I draw? If I'm in a hurry and I may not hit the exact keys, and I mean, like this line shifted to the right, is the recognition based on the form that I draw, or
Yes,
do I really have to
yeah.
hit the keys, basically?
You come pretty close. What it's doing is it's mapping the form of the gesture and a dictionary, right? And so it knows that there are very, very few words that are confusable. So if you offset by a little bit here, it'll still think you did that word. It's not that it gets it right all the time.
But I could not draw a word in the upper part, basically. So
Nope,
I have to,
nope. This part, that's a really good point. This structure is making it possible for those machine learning algorithms to work. And it's not just the shape, it's the combination of the shape
I mean, it
and the
could be the
dictionary.
shape. I mean, the shape is also, I mean, you could shape words.
It would just be less accurate.
Yeah.
So, I mean, there's the trade-off, right? And in fact, what's happening is once I go here, I'm taking advantage of the fact that there's a keyboard layout here. When I go up here, all I have is shape.
Yeah.
Unless I project a color wheel, and then I can do it in the context. Or I slide along the brightness scale. Or I project a menu, right? So, anyway, that forward here. The next thing that we're doing with this is creating what we call expressive typography. So we're working with a professional typographer, and the idea is, if you can see here, this would be the result of somebody walking. And it's a little bouncier, and different types of we're playing games with how that will all work. By the way, I'm not saying that everybody would always want this on all the time. If you're writing a text message to your boss, maybe you want plain old vanilla, send it that way. But a lot of times you want to add emojis and do something that's fun and be expressive, and so this is a way of doing that. All right, now that was using the phone as kind of the white rat experimental subject. How do we think about these different kinds of concepts in a real way? How do we build these human-computer partnerships usefully? But I'll give you another set of examples where we were doing a completely different kind of sort of substrate. Here we're working with musicians, and in particular we're working with contemporary music composers at earcams, so they're people who are kind of pushing the limits. They're the extreme users that Chat was mentioning earlier. But we still have this same need. We have discoverability, appropriability, and expressivity. So let me show you some examples here. So how do I learn musical relationships? Well, there's a technique that was developed by Euler in the 1700s for analyzing music relationships. Now, most of you are familiar with a musical score where you have 5 lines, you have, say, a treble or a bass clef, and you have a series of notes, right? Well, when you're in a particular key, like the key of C if I'm North American, or Do if I'm in France, or probably here, I don't know what you do here. Anyway, so this would be like, this is set up to be a C minor scale or a Do minor scale. And we have different kinds of parts, and this honeycomb relationship is kind of a tone space. It's a different way of laying out the relationships. Think of this as a kind of 3-dimensional in 2D space spreadsheet for playing musical notes. Now, what can we do with that? Well, oops, let me turn this on. We can map it to sounds. So each of those little buttons there is a tone that we can map. And we create this is just paper, ordinary paper with a little dot pattern on it, and that's an Enoto pen, which has a little camera in it. This is actually fairly old technology. It's about, I don't know, 10 years more than that old. But what we're doing is we're mapping between this sort of structure and this here. And this is being used as a composition tool. So we actually interviewed a composer who does this as composition, and then we created this interactive paper environment for him to explore and play. And you can see that we can do both melodies and chords. And look at, you can see the graphical relationship. We get this kind of space, and then he's going to do another one. So it's good to kind of understand, oh, okay, that pattern maps to that pattern, this is what happens. Right? It's a little jazzier. Okay, so the idea here is you can use it as a learning technique, you can use it as a composition technique, you can use it as a just very light way of exploring musical concepts. Okay, so that's what we call the paper tonnets. Tonnets is that honeycomb thing. Now, if I'm talking with musicians, how do we let them define their own commands? Well, we go back and we start out with something that we call naughty gestures. The idea here is, this is again the same kind of paper, same kind of pen. Now what I do is I draw a little dot on a line. And it turns out that from the system's point of view, drawing a little dot, going around, making a dot, is very easy to recognize. Okay? But now what I do is whenever I do that, I associate functionality with that dot. So I'm creating my own interactive environment through this interaction. So here we have an example of creating mathematical relationships. So I have a set of numbers that I've written, and I can draw this and I can say, calculate this. This is my spreadsheet again, but all written by hand. This is a sigma, and I can go and figure out what's going on here. Let me give you another example. I can create a system for recording sound. So I can draw a dot that says, this is a recording, right? If you were recording this and you were writing notes, you would be able to write notes and then say, oh, that's an interesting slide, or I heard about that tonnets thing, and it would be associated directly with what you wrote. All right, now we get a start for recording, an end, and then I can slide the pen back and forth to play the recording. And I believe we will see an example of this here. All right. So you see things changing. So he's putting in a title, he's putting in link audio, and he's putting in, the pen itself records audio, and so he's drawn some stuff, and he's going to make some comments. Let's see that in a second. Here he's doing his calculations, and you'll see that. Not sure where this is here. It's telling him that's the result. Now he's doing this, and it's ready. Dennis is going to do start recording.
This is the first comment.
Very exciting example.
This is the second comment.
Yep. And now.
This is the first comment. This is the second comment.
So you see how that could be used in a lot of different ways. Basically embedding technology in it. Now we've done a variation of this, which we're going to present at Chi next week. Here, I'm going to stop this actually in the middle just to give myself a chance. So we worked with choreographers now, not musicians, but choreographers, and looking at using this idea of knots that are embedding functionality into the drawings that the choreographers are using to capture their dances. Now, there is no standard way of capturing dances the way there is in music. And so they're creating their own. They create timelines and floor plans, and they work through, they often record video as a way of capturing what they've been doing. And so what these are real things that real professional choreographers were using with this system. And then I show you my favorite bit, which is a case of appropriation. Oh, please play. No. Play. There we go. There's Matthias. This guy does Argentine dance. And, oops, I shouldn't have said his name. Anyway. So what he did is he started drawing a notation, and that's a particular way for a particular step. And then he's working with the dancer, which is very common with choreographers working with dancers and sort of their muse. And then they're working through what the dance is, but it's an interactive technique at the moment that they're doing it. So what we found is that it supported lots of different kinds of technology, different ways of interacting. I'll show you a few things. So here, she's creating an interactive floor plan. She's calling it a floor plan, so it has certain properties that she's embedding into these lines. And now what she's doing is saying these dancers go in this particular pattern. She now, sort of like the sticky lines thing, for those of you who saw that, she's scooping up, same actually student, picking up that trajectory. Now she's changing the speed, and you see that these guys finish first, and this person takes a long time to get there. So now what she's going to do is say, I want all of these to end at the same time. And so she puts in the time, adds that property, and now everything works out so that it ends the same. All right? And there's all kinds of things. You can clone that and play with it and interact with it. I think I'll just jump forward because I'm running late. Now, the last one, and it really is the last, is how I can express myself. All of this stuff that you saw before was expressive, but this is another one that I really like. So I had a student, Jeremy Garcia. The last one was Mike Siofi. He was working with a professional professional contemporary music composer, Philippe Leroux, who's at McGill and also IRCAM in Paris. And he was working with manuscripts that look like that from the 13th century. What's interesting about these, and a little bit different than what you would see now, these are of course all handwritten, but they have these odd little flags. You see these? And what's interesting about that is that they didn't have words to express things like adagio or andante. They would draw it as a gesture. Okay? So he said, well, I would really like to have paper-based drawing of these gestures as a composition tool. So we created this technique of the same interactive paper strategy with the same kind of pen, and creating a set of features that he wanted to play with. And then you can do things like the speed at which you draw that, or the order in which you draw it, or the different kinds of things you do can all be mapped into different musical outputs. And so I will...
C'est de réexploiter en fait le graphisme du manuscrit
et
lui donner un sens nouveau en
utilisant
toutes les données qu'on peut en extraire, c'est-à-dire par exemple l'épaisseur du trait.
The thickness of the line is important. So he traces the original manuscript.
Not the original.
Well, not the original copy, sorry. Yes, definitely didn't do the original. And you can see it's showing up. This is the computer-based version after it's been done. So there's a copy online. This is Open Music, which is a system that was developed at IRCAM for interpreting the shapes of the gestures.
Dessiné comme ça, donc il correspond sur la partition, sur le manuscrit de Machaut qui correspond à cet élément-là.
So he's saying there's a
Et
correspondence
qui
between
nous donne donc des trajectoires
writing and the trajectory.
qui sont utilisées là directement par les voix
Notice
sous forme de
computer printout.
glissé. On part cette fois d'un nœud qui est un punctum
Still don't know what a punctum is.
et qui donne donc ces trajectoires-là.
Okay. And then human beings can't play that,
De façon un peu plus
stretches it out
comme ça.
so that human beings can
Et
play
donc
it.
là, ce sont le violoncelle et la guitare en fait qui
So
suivent
the cello and the
exactement
guitar.
les contours de ce nœud.
So who knew that that manuscript was printed that? I don't know. All right. So basically, it shrank my text. How interesting. Basically, my argument is that there's a lot more that we can do in building interactive systems. And that if we start with the idea that human beings are smart, able to learn things, Sometimes they need a lot of scaffolding, sometimes they need that taxi to get home, sometimes they want to be in complete control, and sometimes they want a partnership. We should be able to design interactive systems that let us do that and avoid this model of the world and allow us to eventually really master the technology that we use. And I will stop there. Thank you very much.
All right, we have time for a few questions.
How do elderly people handle those interfaces? Have you tested those with elderly people?
We've done some work with the elderly, but we haven't tested these. I think the problem is not so much whether it's the elderly can or can't, but based on the particular abilities or not of people. And so you would design an interface that the whole idea is that it's incrementally learnable and that the learnability is embedded at the moment that I need it. That support is there. So we're not unaware of the fact that there are people who have either disabilities or eyesight or whatever, and these techniques are explicitly, that's fundamental to the idea, is that you would take those things into account as you design your interface. So it's a good question, and definitely, there's a lot more that can be done. This is kind of showing you a way of thinking, and ideally people will take it up and go with it. Other questions? Yes.
So these gestures, there's like a whole design space for them, right? So do you somehow optimize what gesture you assign to what command and how common it is, and to leave as much space as possible for custom gestures, etc.?
I haven't shown it. We've done some work in that. We've done work with chord gestures where you can use different fingers and get over 400 different chords which can map to different things and make chords then dynamic and so on. If you're on a tablet space, it's a bit small. This is a bit small. Again, that's a tremendous design challenge. And one of the, I didn't emphasize the downsides of these techniques, but one that you run into with this graphic spaghetti that shows up is we've done studies, and if you get more than about 16 different possible gestures at any point in time, it's too confusing to, so it limits how many you can use, which is why if you know the command, it's a combination of different techniques that you can put together. It's also the case that there are researchers trying to figure out what are reasonable gestures to associate with what. You as an individual might want those gestures, or you might want something else, which is why we think you should be able to change them. And I never use that gesture for that, so it's like keyboard shortcuts, it's sort of thing. And some people will change keyboard shortcuts, most people won't. So it's interesting. So again, this is not like commercial stuff. This is a variety of different explorations, and there's a lot more that can be done.
But you had you show field path, but field.
I didn't show pathway. Yes.
Password,
Right.
which was suggesting gestures.
Yes.
What we saw, it was very open-ended. You can do anything, which can be,
It's good or bad, right?
Yeah, good or bad. But there was another version where it would show you possible.
Right. So you start doing a gesture, and it says, "Yeah, that one's like you draw the circle, right?" And it says, "No, the circle's already taken, but here's 4 different things you could do to complete it that would all be really easy to distinguish." And what we found actually is that people started building grammars. So for example, if I have my mom, my dad, my brother, my sister, and my partner, I could have those be in my contacts list as certain types of gesture, and I could have calls, Skype, WhatsApp, whatever, and I combine those two, and people were sort of naturally creating their own gesture grammars, and that's kind of an interesting thing that we haven't explored yet, but it emerged from our user studies. Yes?
This is one of the areas where one has the impression that much of innovation is coming from companies rather than
None of this.
Research teams. But I mean the one that we're actually using in our devices. So my question is, what do you feel are the respective contributions of industry and university research there, and how can you hope to have a real impact on the way we use our devices?
Well, I mean, in some ways, what happens is we're a field where Google and Apple and Adobe and those guys pay attention. So they have looked at the technique that you were showing, the sticky lines technique, and there's various things. We talked to Google about some of these things. There's a lot of stuff I can't talk about. It's very tricky because the large companies have lots of data that we don't have access to and lots of different kinds of things, and they have a whole marketing strategy that may or may not be in alignment with the kinds of things that we propose here. What we're doing is offering possibilities. There are different paths you could take. You could go and, like, for example, there's a fairly major movement going on where graphic designers are protesting Adobe, and they're saying, well, I don't really want everything to be in the cloud. I want to own my own tools and do that. And so there's separate groups that are really driven by graphic designers, and they can adopt these kinds of things for free because we're funded by the French government and the European government. Our stuff is all open source, it's all out there, and we encourage people to use them. So how people adopt it, it varies. I have an example of paper-based stuff that we did in 1998 with paper flight strips, and it took till 2014 for that to be adopted. This studies done in France with French air traffic controllers, and it was finally sold to the British in 2014. So there's a long tail for some of these things to get adopted. Some things get adopted quickly, but not everything. So it's complicated. I mean, that's a whole other discussion, I think. There's a lot of things to say about it. It's
But I'm actually not sure I agree that the innovation in that field has been done in industry.
Yeah,
Everything that's in an iPhone, interface-wise, was done 30 years before.
yeah, there's
They were
nothing
good
new
at
that
putting
we
it
see.
together into one device. But the gesture input, the multi-touch, the
From an interaction technique
was
point of
not
view, he's absolutely
invented
right.
by
Right.
Was it nothing but zeros?
No.
No,
In fact, the
no,
touch
we
stuff
actually
was,
do study this. I worked for Xerox. There are a number of things that were invented by Xerox, but a lot of things that have gone beyond that. The stuff that Xerox did is on your laptop, a lot of that. And actually there's stuff that they invented that still isn't on your laptop, which is sort of heartbreaking. But there's 30 years of research that's gone on since then, and only pieces of that have gotten adopted. And part of the argument that I was making about the phone and why do people not use gesture-based stuff, I've worked with Shuman Jai, who is the guy who invented gesture typing, and he's now a high-level manager at Google. And what he says is the problem is people have hard time learning it, right? So there's a couple of people I saw that use it. So you took the time to learn how to do it, and usually once you do, you don't want to give it up, right? It's something that's really fast. But for the rest of you, if you try it a couple of times, you go, I have to learn, right? It's hard to learn. And so this barrier to doing more innovative, more powerful stuff has partly to do with the fact that it's not incrementally learnable. And so one of the things that we're focusing on, that's why discoverability is important, is to make that path smoother, because people in industry have found that as a barrier to using techniques.
So with an interest of time, I would suggest that the next question you can ask Wendy directly, like in the apero, and we have apero outside, so everybody is welcome to join. So let us thank Wendy again.